Assalamu alaikum. This is lecture 3 of software requirement engineering, and in this lecture I am going to discuss about the role of requirement engineering in software development lifecycle. There will be some discussion about requirement engineering process on the whole, and there will be some discussion about the relevant stakeholders, the feasibility study of the software requirement specification, and risks involved during and after the development of any software product. Software requirement engineer is a person who is responsible to collect the requirements to assemble any software product. Primary responsibility of the requirement engineer is to gather, analyze, and document those requirements and then validate the needs of project stakeholders. The principal conduit between the user and the development team is the software requirement engineer, which flows the information brought from the user to the software development team and from the software development team to the end users. Software requirement engineer is usually a project-based role, and there is no job title for such person, and you usually allocate some specialist dedicated person for a particular project. So it can be a specialist or a project manager, subject matter expert, or even a developer or a user can also be assigned to collect, gather, and analyze, then document and validate the needs and the user requirements. So any person who is assigned this role must have some knowledge about the requirement engineering process. It must have some skills complemented with some training related to the requirement engineering process. Requirement analysts or requirement engineers play a fundamental role in developing, managing the needs of different stakeholders. At initial point, the requirement engineer or requirement analyst is responsible to meet the needs of the users and to convey these needs to the development teams along with managing the expectations of many other stakeholders. So the requirement engineer is responsible to get the business requirements from the project sponsors. It is not necessary that every time a user is a project sponsor, and in many cases, the project sponsor can be any third party which is which is which using the software development team to develop a product for a different kind of user. And there will be some other persons managing those products. So you have to, as a software requirement engineer, you have to gather the requirements about the size and the complexity of the project from the project management team. And there will be some testing required from the user level and development level. So you have to identify functional and non-functional requirements which serve as a contract between the user or a project sponsor and the development team, and finally some testing about the final user acceptance about the product. As I have described earlier, that the first task of the requirement engineers is to define the business requirements. Business requirements help the business or funding sponsor, product manager or marketing manager to define the project business requirements. Perhaps the first question is to ask, why are we undertaking this project? Why are we making any certain product? What benefit we will get from making this product? So business requirements include a statement of the organization's business objective, the end goal of the software product, and the ultimate vision of what system will do or what benefit will be gained from the product. So it also suggests a template for a vision and scope document and work with those who hold the vision to help themselves express it. Then you have to identify the project stakeholders. Who are the main stakeholders, main bodies that drive the force to build the software, and who will be the major factors putting constraints on the software development, and who will be the end users. So you have to identify the user classes as well. So in the start, the vision and scope document will help to identify the important user classes along with stakeholders for the product. Then the requirement engineering works with the business sponsors to select appropriate representatives from each user class and then enlist their participation and negotiate their responsibilities. User representatives might hesitate to participate in the requirement exploration until they know exactly what you expect from them. So you have to write down the contributions required from customers, collaborators, and agree on what appropriate level of participation from each one. So in simple terms, you have to identify and make clear yourself that what you want to collect from the user representative to define business goals and identify stakeholders. You have to have certain questions or questionnaires regarding collection of the information from the users, and user representative must know what questions will be asked, so they should present information in a clear and unambiguous manner. Then the most difficult step is to elicit requirement. Elicit requirement means to fetch out the requirements from the users or stakeholders' mind and put those requirements in a document or specification format. So elicitation of the requirement help user to clearly articulate the system capabilities that they need to meet their business objectives. So it might employ information gathering techniques selected from following list. So you can use interviews to collect information. So you can use facilitated requirement workshops. You can do some document analysis. You can conduct surveys, customer site visits, or you can create business process analysis or workflow and task analysis or event lists complemented with other methods of software requirement engineering. So users naturally emphasize that system functional requirements. So you have to steer the discussions to include quality attributes or non-functional requirements, performance goals, business goals, and external interfaces and constraint. So major task of the requirement elicitation in the software requirement engineering phase takes most of your time. So in this task, you have to identify the functional requirement, non-functional requirement, and performance goals and certain constraints if there applicable to your product. So once you have the information with you, you have a document that contains all the non-functional requirements, all the functional requirements, performance goals, business needs, and objectives along with constraints. Then the next process of the requirement engineer, or the next task of the requirement engineer, is to analyze those requirements. So you have to look for derived requirements that are logical consequence of what the customers requested, for unstated requirements that the customers seem to expect without saying so. So you have to spot out the vague, ambiguous, weak words that cause ambiguity or diffusion between the development team. And then you have to point out conflicting requirements as well. For example, two users may point the same function in a different way, so you have to identify the conflicting requirements and select the unambiguous one, and you have to put more effort in those areas. Then you have to specify the functional requirements at level of detail suitable for use by the development team. The team who will implement those requirements from the high level language to the coding language. So this level of detail will vary from project to project. For example, if you are developing a website for a small, well-synchronized team can get away with the limited requirement documentation. On the other hand, if you are using or developing a complex embedded system that will be outsourced to another company from abroad, will need a very precise and detailed software requirement specifications. After the analysis, the role of the requirement engineer is to elicit those requirements or articulate those requirements in a document called Software Requirement Specification (SRS) document. So you have to write requirement specifications. Requirement development usually leads to a shared understanding of system that will address the customer's problem or the sponsor's objectives. The requirement engineer is responsible for writing a well-organized specification that clearly express this shared understanding. From shared understanding, we mean that all the stakeholders on the same page and they know what each requirement means and what will be the outcome of each function requirement, non-function requirement, any constraint or need of the stakeholder. Using standard templates for use cases and SREs accelerates the requirement development by reminding the analyst of the topics that he needs to discuss with the user representative. So we will be discussing the templates for use cases in the next few lectures, that are some standards for definitions of software requirement specifications. So you can also complement the specifications with some models. So requirement engineers should determine when it is useful to represent requirements using methods other than text. So you can use graphical analysis models such as tables, mathematical equations, and prototypes to represent your requirements. So analysis models depict the information at a high level of abstraction than does the detailed text. So to maximize the communication and clarity, you have to draw analysis models according to the conventions of standard modeling language. And usually a unified modeling language (UML) is used to develop models for requirement specification. We will be discussing about the modeling of the requirement specification in next few lectures. The concluding task for requirement engineers specification document will be leading the requirement validations. So you have to ensure that the requirement statement possesses all desired characteristics and that the system based on the requirements will satisfy the user needs. So you have to validate each requirement with respect to how they are specified and how they are desired by the user. Requirement engineers are central participants in peer reviews of requirement documents. They should also review design, code, and test cases that were derived from the requirement specifications to ensure that the requirements were interpreted correctly. So when first phase of the requirement engineering lifecycle is completed, in which you have elicited the actual requirements, then conducted an analysis on those requirements, specified those requirements in a software specification software requirement specification document, and validated those requirements against users and other stakeholders' need, then requirement engineer should also facilitate the requirement prioritizations, that what requirements have high priority which should be implemented in the first version and what requirements should be implemented in the later version. Requirement engineers are agents in collaboration with the negotiation between the various user classes and developers to ensure that they make a sensible priority decision. Requirement prioritization spreadsheet tool might be helpful in these cases. So as described earlier, a requirement engineer is involved throughout the entire software development lifecycle, so he or she should help create, review, and execute the project's requirements management plan. After establishing the requirement baseline, the requirement engineer's focus shifts to managing those requirements and verifying their satisfaction in the product. So, storing the requirements in a requirement management tool facilitates this ongoing management so that each management tool helps you to keep track of each requirement and verify that each requirement has been met. Requirement management also includes tracking the status of individual requirements as they progress from inception to verification in the integrated product. With the input from various colleagues, the requirement engineer collects traceability information which connects individual requirements to other system elements, managing changes to the baseline requirements by using a change control process and tool. So requirement engineering management tool helps you to manage a number of requirements. For example, for a simple product, you may have 5 requirements, and requirement management tool helps you to keep track of the status of each requirement if each of the requirements has been fulfilled or not. And then you have to satisfy the verification of the product requirement the requirements have been met in the product. And secondly, you keep the track of the traceability information that connects the individual requirements to the other system. For example, in the future these two requirements may be met by another requirement named requirement 6, and additionally it manages changes from baseline requirements to change control process For example, so requirement engineering process is typically represented as a black box which takes input from certain stakeholders and organizations, regulations, and domain information. So usually you can get initial requirements by studying existing system information. For example, if you are going to develop a project or a product and there are similar systems already being built, so you can get the initial information about the functional and non-functional requirements from the existing systems. And then you can conduct the stakeholder analysis to identify the needs of the stakeholders. Stakeholders can be business sponsors, it can be users, developers, or other regulators. There can be some organizational standards which provide help you to identify requirements for a particular project. A certain requirement for organizational standard that you have to develop the requirements in a particular tool, or there must be a particular way of user screen for any product. There can be regulations from any government or any third party regulatory body, and then you can get the domain information from the subject experts, and all the amalgam is mixed in the requirement engineering process, and the output of the process will give you finally accepted and agreed requirements along with the system specifications and system models. So if we take the summary of the previous 15 slides, which can be adumbrated here, that the requirement engineering process consists of two fundamental sub-processes: requirement development and requirement management. Requirement development is the elicitation, analysis, specification, and validation of each requirement. In the elicitation phase, you have to identify the requirement from the user, then you have to analyze those requirements with the requirement specifications, and finally accepted specifications are written in documents and which are again validated by the needs of the users. And along with these four sub-processes, again the established requirements are managed through requirement management process. Let's take a brief look at the each sub-processes. First, the requirement development. So we can further subdivide the requirements development into elicitation, analysis, specification, and validation. These subdisciplines encompass all activities involved with gathering, evaluating, documenting the requirement for a software or software containing product, including following. So initially it is about the identifications of the product's expected user classes, elicitation of needs from the individuals who represent each user class, then understand the user task and the goals that and the business objectives with which those tasks align. So we'll conduct different analysis about the user task and goal analysis. And then after the elicitation and the mapping of the user task and goal with the business objectives, you have to analyze the information received from users to distinguish their task goals from functional requirements, non-functional requirements, business rules, suggested solutions, and any further information. And these steps also include the allocation of portions of top-level requirements to the software components defined in the system architecture, and understanding in the relative importance of quality attributes It also involves negotiations that implements priorities of the requirements that which part of systems have preference over the rest of the system. So it also includes translating the collected user needs into the written requirement specifications and models before reviewing the documented requirements to ensure the common understanding of the user's stated requirements and to correct any problems before the development group accepts them. So on the other hand, requirement management entails establishing and managing an agreement with the customers on the requirements for the software project. The agreement is embodied in the written document called requirement specification documents and models. The developers also must accept the specifications and agree to build the product into them. Requirements management activities include following. So the definition of the requirement baselines is done in the previous step and agreed requirements are specified in the requirement specification documents. The requirement management process reviews the proposed requirement changes and evaluates the likely impact of each change before improving. It also incorporates approved requirement changes into the project in a controlled way, keeping project plans current with the requirements. It also includes the negotiation of new commitments based on the estimated impacts of the requirement changes and traces individual requirements to their corresponding design, source code, and test cases. Requirement management also tracks requirement statuses and change activity throughout the project. There is a fine boundary between requirement development and requirement management. In the requirement development phase, the customers and management teams provide the requirements and there is analysis, documentation, review, and a negotiation of those requirements to specify baseline requirements with which output will be presented in the software product. Requirement management, on the other hand, controls the outcome of those baseline requirements by managing the requirement change and project change. So requirement management usually deals with the tracing where the requirements are met, managing the changes in the requirements in the project or product, and management of the fulfillment of results and confirmation on successful product deployment. On the other hand, the requirement development refers to the elicitation, analysis, specification, and validation of the requirements. The requirement engineering process activities involve requirement elicitation, analysis, documentation, and validation. In the elicitation phase, again, requirements are discovered through consultation with stakeholders. The requirement engineer works with the customers on gathering requirements. In the requirement analysis and negotiation phase, process this information to understand it and classify the information into different categories and relate the customer needs to possible software requirements. Requirements are analyzed and conflicts are resolved through negotiation between different stakeholders and requirement engineers. Requirement document and specification phase is actual transformation of the requirements from the user needs to a document or software requirement specification or user requirement specification model. So it represents the structure of the customer's input and derived requirements as a written document or diagram. A requirement document is produced at the end of this step. In the final requirement engineering process activities, requirements are validated and you will ask your customers to confirm that what you have written is accurate and complete and to correct errors. The requirement document is checked for consistency and completeness. There are many benefits for a high quality requirement process. Initially, if you have a high quality requirement process, you are bound to have a high quality software product. So if you have a better software requirement engineering process, there will be fewer requirement defects which will greatly reduce the development and rework costs. It will have fewer unnecessary information and your product will be straightforward to the desired non-functional and functional requirements. And there will be also lower enhancement costs along with the faster development. And there will be fewer miscommunications because the quality of the requirement engineering process will ensure that the requirements are unambiguous and clearly stipulated to all the stakeholders and especially to the developers and the users. And it will also reduce the scope creep that you do not have to vary your scope with each release. And it will also greatly reduce the project chaos and everything will be streamlined with respect to the schedule. And there will be more accurate system testing estimates because requirements will be specified and validated in a clear and articulate manner. And finally, it is bound to have higher customer and team member satisfaction. But as they say, the devil is in the details. The most difficult process in the requirement engineering is the information acquisition. And the requirement engineers may not be able to fully understand the requirements of the stakeholders, the requirement specification documents, and what the developers are going to produce as a output. So initially, the requirement engineer's task is to identify the problems, and the stakeholders are the initial or starting point to consider it. Stakeholders are relevant to the product and the project needs, and they must have the information about the product domain, and they articulate their requirements to a requirement specification document which must be analyzed by a requirement engineer. So this phase helps the requirement engineer to find out the information about the project or the requirement. And then the requirement is a specification document is provided to developers to to create the final project. At this stage, the stakeholders again use the product to identify further information from the product itself. And additionally, stakeholders can conduct a subject or domain specialist to find out the information about the project capabilities. Several methods can be applied to find out the actual information that is required to build the software project. And the clients is the initial or fundamental stakeholders in the identification of requirement specification. Along with the stakeholders, you can use different methods to formulate your requirements, and the most common is the brainstorming, which can be a session to identify the different ideas which can be catered in the project. So you can also conduct client interviews and meetings to find out the information that what is the actual need or desire, or you can use some product research about already developed product, or you can conduct an ethnography which will help to understand you that how end users are doing the task, so you can automate this task into a project so that end user needs are met. So you can also create an quality attribute workshop to analyze the quality attributes desired by the project. Or you can use different project management teams to identify the doubts using a query tracker. So here are some starting points which help you to create a specification for any project. So you have to be very clear that the stakeholders are a fundamental and most important part of any business initiative, either in the software or hardware product. So stakeholders show the importance of customer links, that how different customers or user classes are interlinked with each other, and you have to identify the relevant stakeholders of your product. So you have to ask a question like this: who are the stakeholders? Then you have to identify the boundaries of the system. In other words, you have to identify the scope of the problem and what implications it, will it have on the development. And then what you want to achieve is specified by the goals and the scenarios, and it is a useful way to organize the initial collection of information. And then you have to conduct the feasibility and the risk analysis, and there are different ways to conduct a feasibility study and how to choose which of the product to pursue from the feasibility study. Feasibility study refers to the application of any software product, and with each application there are several risks involved, and you have to employ a continuous risk management process, and you have to identify risk through hazard and fault analysis. So the software development is usually carried out in four words, referred as usage word, subject word, system word, and development word. So whenever a new functionality is desired, the user or usage word contacts a development word to create a new functionality. The development word, in response to the usage word, creates a new system word which is used by the usage word. The system word usually contains the information about the subject word, and the user word needs the information about the subject word. So for example, a user or the usage word wants to create a university management system, so they contact the development word to create a university management system, and the development word creates the university management system, which is used by the usage word. Now, usage word needs the information about the subject word. The subject word is the university management system, and our system will have the information about the subject word in this case. So you have to find out the subject word. The subject matter of the information system. So you have to identify, for example, customers, account, transaction of the banking system. Usage word is the environment within which the planned system will operate, such as people, managers, clerk, customers, also business processes such as handling a withdrawal or deposit of foreign currency. System word specifies the what system does within the operational environment, what information it contains, and what function it performs. For example, system records all the transactions in the database, reports on transactions, and the development word, the development process, team, schedule, or required qualities, for example, security, performance, for example, system to be delivered in 12 months, fully tested. The stakeholders are primary part, once again reiterated here, that stakeholders analysis is very important and it helps to identify all the people who must be consulted during the information acquisition phase. So you have to look for the stakeholders associated with each of the four words here. The example stakeholders can be users who are concerned with the features and functionality of the new system, the designers who want to build a perfect system or reuse the existing code, system analysts who want to get the requirements right, training or support staff who want to make sure the new system is usable and manageable, and business analysts who want to make sure we are doing better than the competitors. There can be some technical authors who will prepare your user manuals and other documentation for the new system, and the project manager who wants to complete the project on time, within budget, and all the objectives met. And finally, the customer who is paying for the new system. The elicitation phase is the most difficult and most important to manage. As described by Scott Adams Art here, that a user is being interviewed by a requirement engineers to identify the requirements for a specific project, and he is unable to provide the information. So you can go through this art to clearly identify the problem here. However, it is reiterated that elicitation is the most difficult problem because of the unambiguity of the human languages, and there is so much different interpretations of same words in the different heads. So there is a thin spread of domain knowledge, which is a major difficulty of the elicitation. The knowledge about the system might be distributed across many sources, so it is rarely available to explicit form. So there will be conflicts between the knowledge from different sources. People have different goals and people have different understanding of the problem. So you have to find out the right stakeholders to elicit a better requirement specification. And there is some tacit or implied knowledge. For example, people find it hard to describe the knowledge they regularly use. For example, you use or do a regular activity which is so normal to you, and you think in your mind that the other person will understand that it is a normal way of doing a job. So this can be a problem for requirement specifications, and descriptions may be inaccurate rationalization of expected expert behavior. And there are some chances of limited observability, that the problem owners might be too busy solving it using the existing system. The presence of an observer may change the problem. It is often referred as probe fact. And there can be some bias problems. People may not be free to tell you what you need to know. And there can be some political climate and organizational factor matters. People may not want to tell you what you need to know. The outcome will affect them, so they may try to influence you by using some hidden agenda. So, in short, the problem arising in the difficulty of elicitation is the lack of knowledge or some implied knowledge which the end users think that the developers will understand, limited observability that they limit their access or other person's access to observe a task, and there can be some bias or other agendas to mislead the requirement engineers to create difficulties in the elicitation. For example, we have a problem area example here that we need a loan approval department in a large bank, and the analyst is trying to elicit the rules and procedures for approving a loan. So this might be difficult because of implicit knowledge that there is no document in which the rules for approving loans are written down, so you have to find out the information by interviewing others. So you can get some conflicting information because different members of the different departments have different ideas about what the rules are. So there are some say to rules. Loan approval process described to you by the loan approval officers is quite different from your observations of what they actually do. So again, the probe effect, the loan approval process used by the officers while you are observing is different from one they are normally use. And there you can also observe some bias that some loan officers or loan approval officers fear that your job is to computerize their jobs out of existence. So they are deliberately emphasizing the need of case-by-case discretion to convince you that it has to be done by the humans. So in this case, you have to conduct feasibility studies of different alternatives and choose the best alternative from those options. So the objective of the feasibility study is to find out if a software development project can be done, is it possible, and is it justified. So to suggest the possible alternate solutions. It is also used to provide management with enough information to know whether the project can be done again and whether the final product will benefit its intended user and what the alternatives are and whether there is a preferred alternative. A feasibility study is a management oriented activity, and after a feasibility study the management makes go or no go decisions toward the product. So you have to need to examine the problem in the context of broader business strategies. There are some certain elements which needs to be studied in the feasibility study. For example, the present organization system, the users, policies and functions and objectives are critical part of the feasibility study along with the problems of the present system, such as inconsistencies, inadequacies in the functionality and performance. Once you have identified the present scenario, then you can identify or enlist the objectives and other requirements for the new system, that which problems need to be solved and what is needed as a change, then what is the problem to inculcate that change in the organization is referred as constraints, which includes the non-functional requirements on the systems and possible alternatives. Here that what is the benefit of sticking with the current system should always be studied as what one alternative and different business processes for solving the problems and different levels of computerization for the solution, along with the advantages and disadvantages of the each alternative. So you have to consider about the things to include in the feasibility of the project and the preferred alternatives. And there are different types of feasibility studies which are done at the different levels. For example, technical studies, schedule, feasibility studies, and operational studies and economic studies. Technical studies, as the name suggests, is referred with the needs and advent of the technology. It is the project that whether the project is possible with the current technology and how much the technical risk is there. So you have to ask the question that does the technology exist at all? Is it available? Can it be obtained? Will it be compatible with other systems? And along with that, you have to conduct economic feasibility as well. That whether or not you have the resources to make the project possible and what benefit will be resulting from the system, the both tangible and intangible benefits, and you have to quantify the end product gains. So what are the development and operational costs and what are the benefits, what is the worth gain and what is the worth lost. So gradual feasibility is important because, as we say, a stitch in time saves nine, and if you are not on the schedule, you can harm your organization with the development of new system rather than benefiting. So you have to ask the question: is it possible to build a solution in time to be useful? Because if the solution is built late, and then it is desired, there is no significant uh, cost value. So you have to identify the constraint on the schedules and can these constraints be met. And finally, the operational feasibility refers to the urgency of the problems and the acceptability of any system, that if the system is developed, will it be used. You have to cater the human and the social issues, internal issues such as available of human resources, whether there is any technical staff, potential labor objections, management issues, manager resistance, organizational conflicts and policies, and external issues such as social acceptability and legal aspects of the government regulations. You have to identify benefits and the cost in terms of tangible benefits, intangible benefits, and cost in terms of development cost and operational cost. Tangible benefits are the relatively readily quantified as dollars values. For example, development of system has some increased sales in terms of numbers. It has increased cost or error reduction. So sorry, it has decreased the cost or error reduction. It has some increased throughput or efficiency, or it has increased margin on sales or more effective use of staff time. So there are some intangible benefits as well, such as which are difficult to qualify, but may be more important. So these are business analysis that helps to estimate the number of dollars that you save. For example, in the intangible benefits, you can find out the increased flexibility of the operations in your systems, or higher quality product services, better customer relations, and better customer satisfactions, or improved staff morale. And you have to identify that how benefits will enhance your system capabilities, when and over what timescales, and where in the organization. Development, the costs or development and operational costs. Development costs, as the name suggests, are the development and purchasing costs, the cost of development team, consultation fees, software used for to buy or build, hardware, facilities, etc. It also includes installation and conversion cost of installation of the system, training personnel, and file conversions. Operational costs refer to the system maintenance and personnel used for those using the system. Maintenance costs also refer to the hardware and software costs of repairs, lease, supplies, licenses, and contracts, and facilities. Personnel for operations of data entry and backup, for support users and hardware and software maintenance, and supplies and ongoing training costs. The important aspect of feasibility study is to analyze costs versus benefits. So identify the costs and benefits in forms of tangible and intangible, one-time and recurring. Assign values to the costs and benefits and determine the cash flow that project costs and benefits are over 3 to 5 years. So you have to calculate the net present value for all future cost benefits. Determine the future costs or benefits of the project in terms of today's dollar values. A dollar earned today is worth more than the potential dollar earned next year. So you have to ask the question, do cost slash benefit analysis produces some positive value? So you have to calculate the return on investment, which allows comparison of lifetime profitability of alternate solution. Return on investment is calculated by lifetime benefits minus lifetime cost. So you have to calculate the break even point. How long will it take in years to pay back the accrued cost? Accrued costs are initial and incremental costs, and which must be less than the benefits of your project. Another important aspect of your requirement engineering process is the risk management, and it is a systematic activity requiring both technical and management attention. It requires system low-level view, and it should continue throughout a project. There are different techniques exist to identify and assess risk. For example, fault tree analysis and risk assessment matrix are two examples. Risk and requirement engineering go side by side, and risk analysis can uncover new requirements, especially for safety critical and safety critical applications. Risk analysis can uncover feasibility concerns. Risk analysis will assist in appropriate management actions as well. So there are some straightforward risks which are referred as main risks. For example, at the start there is insufficient user involvement, there is creeping user requirements, ambiguous requirements, gold plating, minimal specification, overlooked user classes, and inaccurate planning. So all of these risks can be handled by using one of the risk analysis method and risk management techniques. So there are different stages of risk-based analysis. So again, it starts from the risk identification. with the identification of potential risks that may arise, and then you have to analyze and classify risks with respect to the seriousness of each risk. Then you have to decompose the risk to discover their potential root causes, and then you have to derive a reduction assessment to define how each risk must be taken into eliminated or reduced when the system is designed. Risk development specification start with the risk description, risk assessment, root cause analysis, and dependability requirements. Risk analysis process can be divided to create a phased process, and initially a preliminary risk analysis is carried out to identify risks from the system environment itself. It aims to develop an initial set of system security and dependability requirements. Then you can conduct another risk on the life cycle or software development life cycle, which identifies the risks that emerge during design and development. For example, the risks that are associated with the technologies used for the system construction requirements are extended to protect against these risks. The final risk analysis can be done at the operational level, in which the risks are associated with the system user interfaces and operator errors. Further protection requirements may be added to cope with these kinds of risks. So that concludes today's lecture, and in this lecture we have discussed the role of the software requirement engineer in the software development lifecycle process and software engineering process, along with the discussion of the feasibility study and risk management. And if you want to read more about the topics, you can look into the recommended book, chapter 4 and chapter 12. If you have any question, you can ask me. Thank you very much.